Okay, guys, it is Friday, April 3rd. We're in Advanced Math, Mod 7. Our fifth and final topic for the week. The title of today's notes is again quadratic trig equations. Same topic we started to cover yesterday. Again, the date in the top left corner of your paper should be 4/3/20, Friday, April 3rd. Just like yesterday, it'd be great if you could divide your paper into 4 parts or 4 sections. And we'll try one quadratic trig equation in each section and then get you your 4 problem assignments when we're done. Okay, let's focus on block number 1 here. Hey guys, obviously if you look, we've got an equation because there's an equal sign. We've got the word sine and the word cosine, so it's a trig equation. And because one of the words is squared, at least one of the words is squared, it is a quadratic trig equation. Now, if I'm looking at this first one thing should kind of stand out at you. That says sine squared. Oh no, and over here we have the word cosine. Oh, and those words aren't the same. They don't match. Something's not right. We need to try to get creative here to see if we can somehow get this equation into standard form. And this all goes back to way back our last day or two together before we left. Remember when we were doing the trig identities? We had a formula, let me remind you, that said sine squared plus cosine squared always equals 1. Does that ring a bell? If not, you can look it up in your notes if you have to. Sine squared plus cosine squared always is equal to 1. So at that time, when we were practicing some identities, we said that if you ever got one of these values by itself, let's say we were trying to get sine squared to be all by itself, couldn't we subtract over the cosine squared? And sine squared would equal 1 minus cosine squared, just by manipulating that algebraically. So it is true that if we ever see sine squared, we can change it to 1 minus cosine squared, which obviously is what I'm thinking we're going to have to do here, because by doing that and making that switch, it's going to allow this equation to have the same word cosine throughout. So guys, step number 1, because the words involved in this problem are different, we're going to take the word sine squared of x and make it 1 minus cosine squared of x and leave the right side alone. That'll be step number 1. Now, obviously, we would use the distributive property. 2 minus 2 cosine squared of x equals 2 plus the cosine of x. And because this is a quadratic equation, we want to get all the terms all shoved over to the same side and get it equal to 0, because remember, that's called standard form. Well, when we do that, remember, the squared term, you never ever want him to be negative. That is a no-no. So that's telling me to take these two things here on the left and shove them over to the right side and get everybody over there on the right side of the equal sign. So when they leave and go to the other side, I've got 0 equals. Obviously, I'm going to add over the 2 cosine squared of x, and he'll now be on the right side. Agreed? The plus cosine x was already over there. Now notice there was a 2. But aren't we going to subtract over the other 2 and move him over there? So if that's a 2 and we minus over a 2, the 2's end up canceling and disappearing. So now when I go to solve this quadratic equation, it's pretty obvious they have the word cosine x in common, correct? You factor out the cosine of x. When you do, it leaves you with 2 cosine of x plus 1. Agreed? Because think about it, when I distribute to check my answer, cosine times 2 cosine is 2 cosine squared, and cosine times 1 is cosine. And because they're dot connected, I can now do the old let's split those apart step. I would have cosine of x equals 0 and 2 cosine x plus 1 equals 0. When does cosine equal 0? I'm going to go to my trusty unit circle here. When is the x-coordinate 0? That happens up here at pi over 2 and down below at 3 pi over 2. So angle x equals pi over 2 and 3 pi over 2. Those are two of your answers. Here, of course, to get cosine by itself, wouldn't I subtract over the 1 and then divide by the 2 and get cosine x equals -1/2? So again, referring to our unit circle, when does cosine, when is my x-coordinate equal to -1/2? I take a look and I notice that occurs at 2 pi over 3 and again right here at 4 pi over 3. So the other answers, I'll put them down here, are 2 pi over 3, wow, and 4 pi over 3, and we did it. Okay, that was a tough one. Next one. Oh my gosh, once again, I've got two different words, don't I? Once again, I'm going to think back to that day of trig identities. And if you'll remember our last day or two together, when we were trying to solve trig identities, remember I tan in seconds? We had a formula that said 1 plus tan squared equals secant squared. I tan in seconds. 1 plus tan squared always equals secant squared. So it's pretty obvious. I'm trying to get at what point here. That secant squared that's in this problem can get changed to 1 plus tan squared. I can replace it. It's substitution. The secant squared, since it's equal to 1 plus, that's going to get replaced by 1 plus tan squared. So this now becomes 1 plus tan squared of x plus tan of x equals 3. I've got an equation with a squared in it, correct? So once you shove the 3 to the left side, combine terms and put everything in descending order. So that's telling me we've got tan squared plus tan. Now there was a 1 over here, but I'm minusing over a 3. So 1 minus 3 gives me -2 equals 0. I have a quadratic equation written in descending order with everybody on one side. So we're now going to try to what? Take that trinomial and factor it like we did yesterday. Obviously, tan squared is tan times tan. I have a minus at the end, so my signs are different. Plus and minus. And wouldn't I put 2 there and 1 there, because a +2 and a -1, when I combine them, give me the +1 that's in the middle, and it matches my middle term. So I factored it correctly. Because they're dot connected, when I split these up and set them both equal to 0, I would end up with tan x plus 2 equals 0, tan x minus 1 equals 0. So tan equals -2 and tan equals 1. And I would then have to look things up on my unit circle. Okay? Now I know tangent always equals 1, because remember tan is always y over x. It's sine over cosine. So when are the y and the x coordinates exactly the same? That happens at what? Pi over 4, and right here at 5 pi over 4. So my answers are pi over 4 and 5 pi over 4. Now the question becomes, when does tan equal -2? And when I try that one there, this is to kind of prove a little point. If that looks confusing, hey guys, you're always allowed to look at a calculator, correct? Couldn't I, at this point on my calculator, since I'm looking for a missing angle and it's not one that I'm used to seeing on my unit circle, if I hit inverse tan, hit second tan, -2 and hit enter, oh, I get an answer on my screen of -63 degrees, okay? So if you ever get an answer that you can't find the result on your unit circle, it simply means pull out your calculator and do inverse tan of that number, because we're looking or seeking a missing angle. So angle X would be -63 degrees, and we can go with that as the found answer for that part, okay? Come down here to block 3. The good news is we've already got tan squared by itself. And you guys know that the opposite of squaring is what? Square rooting. So my initial thought is let's just square root both sides. I get the tan of 3x equals radical 3. Now for a second, I'm going to pretend that that just says tan of x equals, when does tan equal radical 3? Now guys, remember that tan is y over x because it's sine over cosine. So when I look at my unit circle and I'm trying to figure out when would y over x give me radical 3? When I look at this unit circle and I go to pi over 3, my y coordinate is radical 3 over 2 and my x coordinate is 1/2. Agreed? So think about it. If I take radical 3 over 2 and put it over 1/2, the 2's match, so they would cancel, and it would just leave me with the radical 3 I was seeking. So tangent equals radical 3 at pi over 3. There's one answer. Now remember, that's positive radical 3, so when else would my two signs be the same? Right here at 4 pi over 3, right? Because you'd have negative radical 3 over 2 over negative 1/2. The 2's would cancel, the negatives would cancel, and I would again be left with radical 3. So it looks like the two answers are, notice guys, notice this says 3x though, not just x. So I'm going to write 3x equals pi over 3. And 3x equals the other answer, which was 4 pi over 3. And now to get x by itself. So remember, this is kind of back to what we pointed out yesterday. If there's ever a number here that's not just an x, but in this case a 3x, you've got to take that number, set it equal to each of our answers. And now I divide by 3. Now instead of putting divide by 3, I'm going to put times by 1/3, giving me x equals pi over 9. Here I divide by 3, and again, instead of divide by 3, I'm going to times by 1/3. My other answer is 4 pi over 9. Wow. If you need to pause and relook at that, do it. Sometimes it helps to just pause, write the problem over, try it again, make sure you understand the steps that I just pointed out. Finally, the last problem, secant squared x minus 4 equals 0. Oh, on this one you have two choices. I could add over the 4 and then square root both sides, or I could split this up as the difference of two squares. Most of you would probably have noticed option 1. So let's throw the 4 to the other side. I get secant squared x equals 4. Square root both sides, and secant x would be what? Plus or minus, and of course the square root of 4 is 2. Now technically, remember, that says secant. We don't like the word secant. We like our three main words, sine, cosine, tangent. So what do? Secant is what? The reciprocal of cosine. Agreed? So we're going to write cosine of x equals, and I'm allowed to change secant into cosine as long as my answer gets what? Reciprocated or flipped. So obviously, since he's understood to be over 1, this is plus or minus 1/2. So really, my angle X is going to be all the times when cosine equals either positive 1/2 or negative 1/2, which when I look at my unit circle, occurs at pi over 3, 2 pi over 3, 4 pi over 3, and what? 5 pi over 3. So my answers to this last question are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So guys, that's about as tough as it gets. Quadratic trig equations, you got to really focus on number 1, making sure the words are all the same words. Number 2, get it into standard form so you can actually factor it and solve it correctly. And then number 3, focus on your unit circle and what you need to do to find the correct answers. That's a little more advanced than anything we've done this week. It's a good way to end the week and actually end this chapter on equations involving trig words. So, for Monday, today is Friday, April 3rd. So the 4 problems I'm about to give you are not due till noon on Monday. That'd be what, April 6th? Obviously, if you get them done before then, you can take a picture of them and send them to me anytime you want. But the deadline is noon on Monday. Your 4 problems to do, we'll call it homework. It's really just your assignment to make sure you understand how to attack and do these. Would be these 4 problems right here. First one, cosine squared x minus 1 equals sine of x, almost identical to what I did on my first problem today. Remember, if you get stuck, you can always go back and rewatch parts of the lesson I just presented. Question 2, again, looks very similar to what I just did. Negative 3 plus secant squared of x equals negative tan of x. Negative 3 plus secant squared of x equals negative tan of x. Third question, tan squared of 2x equals 1. Tan squared of 2x equals 1. And finally, problem 4, cosecant squared of x minus 4 equals 0. Of course, that's just like the last one I just did that said secant squared of x minus 4 equals 0. So these 4 problems, make sure you've got them all written down. Show some work. Try to do the best you can. Circle and answer. And as always, your problems are graded for, yes, effort and completion, but also a proper step and a proper answer. So correctness is important. We're evaluating how you understand the topics that I've been giving you. Okay? All right, great job, guys. We'll see you on Monday.